So as you can see, this is from Unit 6 on circuits, and it's about all the series circuits. And really, in this first one, number 1 here, you're just supposed to write really what each quantity is here. So I'm thinking this is what your teacher is getting at, is that let's say bulb 1 is 5 ohms. Ohms is a measure of resistance, and so you'd say R1 because you're talking about bulb 1, and that is 5 ohms. Bulb 2, this is 3 joules per coulomb. Now, joules per coulomb is measuring voltage. So the quantity is voltage. So we would write that as V2 is equal to 3 volts. Bulb 1 is 12 joules per second. Joules per second, you can see over here, joules per second is a unit of power. So we would write P1, and that would be 12 watts. A watt is a joule per second. In number 3, or bulb 3, 4 amps. Amps is short for amperes, which is current. So we would say the current through bulb 3 is 4 amps. And for the battery here, the battery is 10 volts. The voltage, that's a measure of voltage, and that's 10 joules per coulomb. Now, I think your teacher would want the voltage of the battery. Okay, the battery here, so I'm not sure what notation, but the voltage of the battery. And remember that when you're talking about a series circuit, the voltage of the battery is going to be divided up by the voltage drop as the sum of the voltage drops of each bulb, depending on their resistances. Now, you can see that I circled letter C here because that in a series, the current is going to be the same through each bulb. Now, depending on what the resistances are, the voltage drops may be different for each bulb. So the voltage here is going to be broken up across the bulbs here. So this might have a voltage drop of 5, this might be 2, and this might be 1. And if you have 5, 2, and 1, then the total voltage drop is 8. So the voltage of the battery here would be 8. Now, in number 3, I just wrote out 3 formulas. Power equals current times voltage. Current is voltage over resistance. And if you rearrange this equation, you get V equals CR, current times resistance. Now, your teacher is saying don't forget your answer to number 2. And so I'm assuming here that the current is going to be given to you. So if the voltage of each bulb, that's the voltage drop across each bulb, if you're trying to find the resistance, then you could use this formula. If you're given the current and you know what the voltage drop of each bulb is, then you can figure out the resistance. So here, if you're given the voltage of each bulb, and you're given the current in the circuit, then you can figure out the resistance of each light bulb. This is not really necessary. Okay, this is not really necessary. The voltage of the battery, if you're given the current, but there needs to be some other information given than just the voltage drop of each battery here. And then, and I'm assuming it's going to be current. Now, in the last part, the resistance of each bulb, if you're given the resistance of each bulb, then if you're also given the current in the circuit, then you can get the voltage drop for each bulb. Once you're given the voltage drop, then you can use the voltage drop and the current to get the power of each bulb. But after you look this over, we can talk about it later, just in case more information is given.